Hi class, this is Miss Leisure. Once again, it is time for geometry. We're going to talk about similar polygons, and we're going to use all that stuff we talked about yesterday with ratios and proportions. So here we go. Alright, the Common Core state objectives are there, and at the bottom, these are our class objectives, and we're working on numbers 2 and 3. Using proportions to identify similar polygons, yes, and then solving problems using those properties. Alright, so here's the key to this whole section. Similar polygons have the same shape, but not necessarily the same size. So it's kind of like me taking a picture, putting it on a printer, and saying zoom and make it bigger so it blows it up. But it doesn't make it fatter, it just keeps the normal perspective, or ratios as you might say. Alright. So here's where we're going to start filling in our notes. With the definitions and symbols, similar polygons. These polygons are similar if and only if their corresponding angles are congruent. So make sure you're filling in your notes. And the measures of their corresponding sides are proportional. So you can pause this and get this written down. Same shape, different size. Alright, and here we have our symbol. It's a wave, just like the top of the congruent symbol, but now it's not going to be equal anymore. It's not going to be the same or congruent. It's similar. So they're same shape but different size. Alright, and down here we have our two pictures here. These are similar. This one's smaller, actually by 3 times smaller than this one, and that's because I know 15 is to 5. 5 is 3 times to get to the 15. Alright, and here is our similarity statement. We'll talk about that in just a second. Oh, there we go with the highlights. Alright, order is very, very important when it comes to your similar polygons and your similar statement. So your similarity statement is here. And notice that the P is first, and it matches with the K. That's angle P is congruent to angle K. Also, the A is second, and it matches with B, the second one. Angle A is congruent to angle B, and so forth. So make sure you fill out your notes with these. Then you can look at the 2 letters. So you can look at PA matches to the first 2 letters KB over here. So PA is to KB. And then I do the second and the third letters. AT to BU, the third and the fourth, TH to UN, and then I go and use the last and the first. HP is to NK, and this is our corresponding or proportions as far as the sides are concerned. So make sure you get your notes filled in. Alright, example 1. Determine if this pair of figures is similar. Explain your answer. First is always to check the angles to see if they're congruent. And right here you can kind of tell that these are not going to be congruent, but we'll go ahead and go through the steps. So we have an isosceles triangle here, and if 2 sides are equal, you have 2 angles equal. You'll know that by the end of this year, I promise. Alright, so we plug it in, we name them both X, and we plug it in and we end up with X is 70. So both of these angles are 70 degrees. And then we do the same thing for the next one, but I name them Y, and I plug those into the sum of the triangle, and I get Y is 75 for this one. So both those angles are 75. So no, the angles are not congruent. So therefore, these triangles are not similar because the corresponding angles are not congruent. Example 2, determine whether the pair of figures is similar. Justify your answer. So just like the last time, first you want to check the corresponding angles and see if they are congruent. Second, you want to check and see if the corresponding sides are proportional. So if you look at these 2 triangles, we have the 80-60 in both of them. And there is this theorem called the third angle theorem for a triangle. And that is if you have 2 angles congruent, 2 corresponding two angles in another one, then the third angles will be congruent. But we'll go ahead and show it to you, and so I named it x and solved, and I ended up with x is 40, and in the second one I used y, and I ended up with y is 40 as well. So we know that all of our angles are congruent. So number 1 is checked off. It's done. Now we're on step number 2. Check to see if the corresponding sides are proportional. So I started writing my proportions, and I used the BA first. BA between the 60 and the 80. And I go over here to the 60 and the 80, and I say, okay, so that's PI. So BA is to PI. That's where this comes from. Alright, and then I set the next proportion to be the AT is to the IN, okay, between the 80 and the 40. And the last one is the TB is to the NP, the bottoms. So I'm going to fill those in, and then I grab that handy dandy calculator, and I divide 5.2 divided by 3.1. And 7.7 divided by 5.25, and 8 divided by 6. And what happens is that we end up with 1.3 repeating for each one of those. And because these ratios give me the same decimal, then we know that the sides, the corresponding sides, are proportional. So we know the angles are congruent, we know the sides are proportional, so we can say that triangle bat is similar to triangle pin, because the corresponding angles are congruent and the corresponding sides are proportional. Okay. All right, example 3. An architect prepares a 12-inch model of a skyscraper to look like a real 1,100-foot building. What is the scale factor of a model compared to the real building? So, scale factor does not need to have the same units. They can have different units. Okay, and I'm going to use the letter SF for scale factor. So I drew me some pictures, and you know I'm big on pictures, so draw the pictures. And then I looked to see if I could find something that told me about the ratio. And it does. Here's that word 2 right here. That usually signals it's a ratio here. And it says do the model to the real building. So that's the ratio we're going to write. So I plug it in, the 1,100 foot to 12 inches, and I reduce, and I end up with 275 foot to 3 inches. So that means, excuse me, that every 3 inches of the model actually represents 275 feet of the real building. That's it. Scale factor, here's some examples of where you see scale factor. Model cars, model architects, games, video games, a lot of that stuff where you're making them and stuff, and maps. So that's the end. I know you've got more notes that I gave you, but we'll fill those in maybe during class if we feel like we need to go further. I look forward to seeing you in class tomorrow, and have a great afternoon.